Hello everybody, this is our video number 8 on the same topic, relation and the function. And today in this video we will discuss about the two new concepts, and it is very important as per the another chapters that like that the inverse trigonometric functions. So today the first topic is the compositions of a functions, and the second one is the invertible functions. Okay, so the first, what is the definitions or the meaning of this composition of the functions? If a function f from a to b and another functions g from b to c, then the compositions of f and g is denoted by the g of f, and this particular notations, and this notation is read as the g of f. So it is read as, okay. So at first the composition function, we need the minimum two functions. The first functions f from a to b and another function b to c. Then the compositions of f and g is denoted by these special notations g, and it is read as the g of f. And this time the g of f is from a to c, and it is defined as the g of f is the g of fx. Okay, this is the mathematical definitions of the compositions of two functions. So first we consider a set. This is the set, and this set is A, and contain all the elements X form. The another set is B, and it is supposed to contain Y, and this one is our C, and it is contained G. Okay? So as per our definitions, f is a function from a to b. That means f is defined in this manner, and from the second one, the g is another function. It is from b to c. So from the b to c. Okay. So this time from this we can write the y is equal to fx. Okay, and this time from this we can write the z is equal to g dy. Okay, we already know that what is the logic behind it, and from this, as per the consider the definitions of the compositions of functions g and f, that means this time this is nothing but the g of f. Okay, so from this we can write the z, that means the z a to c, that means the z equal to the g of x. So the z equal to z with map with the element of this x. At this time this is the domain with respect to the g of f, and this is the codomain. So that means the z is equal to g of y. This is the given relations, and from this we can write the z of, what is the value of y? Fx. is nothing but the relation of the G of F. So this is the fundamental and this is the logic behind this notations. Remember this one. Okay? Next, invertible functions. So what is the definitions of the invertible functions? If f is a function from x to y and is defined to be invertible, if there exists a function g from y to x. So f is a function from x to y and it is called the invertible functions. So what is the conditions to call this f is an invertible function? The condition is that for this, if f is an invertible function as a defined, then there exists another function g from y to x, and such that the g of f is equal to ix. It is not the meaning of this one is the identity functions on x. So identity function of x and f of g is equal to the identity function of y. This is the symbolic notations for the identity function on x, and this is the symbolic function, the identity function on y. Then g is called the inverse of f and it's denoted by a sign f inverse. Okay? So this is the definitions of invertible functions. The first, f is a function is called the invertible, and from this f function is defined as the x to y. So there exists another function for this f, that is the g. Suppose it is denoted as g, and this time the g, there is a function from y to x, and another two conditions also involved. In this case, the first one, if you find out the g of x, it is produced the identity functions on x, and f of g, it is produced the identity function on y. Then g is called the inverse of f, and it is denoted by this symbol, the f inverse. That is the definitions of the invertible function. And one thing is, remember, for the invertible functions, as for the mathematical proof, sometime when the definition of f inverse is not defined actually, then we try to prove, because it is a property of this invertible function. If f is called the invertible function, that it is implies that f must satisfy the two conditions. F is 1 1, f is 1 1, and onto function. Okay, that means f is bijective functions. If any function f is satisfied the bijective function criteria, then we say that these functions may have the chance to get the inverse of this particular function. So any functions, if you try to find out the inverse of any function, the first check that these functions must satisfy the two conditions. That was the function is 1 1, and onto that means that this function is also hold the bijective criteria. Then these functions may have the chance to get the inverse property, or these particular functions may have the inverse. So this is the definitions of this composition of functions and the invertible functions, and this invertible function is This invertible functions concept is totally based on the compositions of the functions, and this composition function the totally based on the fundamental concept of the function and as well as the criteria of 1 1 and on 2, because the 1 1 and on 2 is involved for these invertible functions, and this compositions of the functions is depend on the fundamental concept of the function definitions. So that's all for the today's lectures. Thank you everybody.